It is with my great pleasure to introduce our moderator, Philippe Degrez, our VP of Downstream Marketing and Communications Channels here at Accuray, who will introduce our presenters for today and moderate the Q&A session at the end of the presentations. Thank you again for joining us today. Philippe?
Thank you. Thank you, Lindsay. Welcome to this MyAccuray webinar, which is more dedicated to new product introduction. Today we'll be talking about ClearRT, which is our onboard kVCT imager solution. And ClearRT offers planning-like image quality, CT image quality, and is fast in a nutshell. We'll have two speakers today. Dr. Lane Rosen, it's my pleasure to have you on board today. You're from Shreveport, Louisiana. That's very familiar for French. Louisiana was kind of an old province of France, 2 centuries ago. It's no longer the case, by the way. Dr. Rosen is an Accuray tomotherapy user of the first days since 2003, which is almost 2 decades, by the way. And you were using tomotherapy for its exquisite dose distribution. Dr. Rosen, your radiation therapy department at Willis-Knighton Cancer Center owns the next generation technologies from proton to photon and to brachytherapy. It offers SRS and SBRT hypofractionated solution to image-guided radiation therapy, helical and arc-based solutions. You were the first site worldwide equipped with ClearRT, the helical kVCT solution, our new onboard kVCT imager, and you will tell us more about it in a moment. Our second speaker is from Accuray, Madhavi Kapa. Madhavi, we were together at Istro just a week ago, and we were broadcasting live another webinar. Madhavi is truly an international leader with a global view on new product creation. Madhavi has more than 15 years of experience with Philips Radiation Oncology. Madhavi is the Senior Director for Tomotherapy Product Strategy. Madhavi, let's start with you.
Thank you so much, Philippe. Let me slide here. So, hello, everyone. I will just provide a short introduction to ClearRT helical kVCT, Accuray's innovation in imaging, before I hand it over to Dr. Rosen, who will share his clinical experience with it. So for those of us who are new to the Radixact system in the audience, it is the latest evolution of tomotherapy. It's a true helical system with high fidelity imaging and ultra precise delivery to treat a broad range of indications and case complexities. And what you see here on the slide are the features and benefits you get with the Radixact system. But today we are here to talk about the latest innovation, which is ClearRT helical fan beam kVCT imaging for the Radixact system. So as Philippe said, in a nutshell, ClearRT helical fan beam kVCT is designed to provide flexible, fast, and exceptional imaging. So the helical multi-row fan beam implementation is similar to diagnostic-CT, and it's designed for fidelity and clarity. And in addition, it provides exceptional flexibility for viewing the most patient anatomy of any radiation system on the market. And finally, the KV imaging system is fully integrated. It provides seamless workflows, including integration with Synchrony, which is our real-time delivery adaptation, as well as PreciseArt, which is our automated daily dose trending and adaptive replanning solution. So the KV system is fully integrated within the Radixact linear accelerator. Here is the 5-step treatment delivery workflow. So it's even with kVCT, it's very simple, where you position the patient, you scan, register, treat the patient, and provide any post-treatment assistance that the patient may need. So the treatment workflow with kVCT is very similar, and it's well integrated into the treatment delivery console. And here you see a view of the treatment delivery console for the Radixact system. So it's the same user interface for all cases, and it's consistent across all indications. So it is that same three-step of scan, register, treat. You pick your scan type, whether it's kVCT or MVCT. You pick the field of view and the scan length that you need, and you go ahead and scan and start the process. What's also available is the ability to view the imaging dose that the patient is getting with the scan. We know that this is something that's globally is being regulated, and so with this release, we also provide you the imaging dose for both kVCT as well as MVCT. Okay, so how does the kVCT work? So as you know, the helical acquisition, it really enables clinicians to choose the most appropriate scan length for every patient with continuous couch motion while the imaging system rotates around the patient. So there are really no junctions in the scan. And you can scan up to 135 centimeters. So the acquisition is really fast. It is capable of scanning a full meter in a minute. In addition, the movable KV panel is designed to provide flexibility, so you can select the imaging field of view up to 50 centimeters, and that really allows you to include more patient anatomy. So not only can ClearRT enable you to see more of the patient, it's designed to provide more clarity in those images for viewing the anatomy. And this is accomplished by using a dynamic fan beam implementation. So it allows clinicians to select, coarse mode or faster mode with a wide fan beam, or a higher quality mode or a fine mode with a narrower fan beam. And there's also in the middle, we have something called the normal mode, which allows you some flexibility in choosing the width of the fan beam. But in all of these cases, the beam is still narrow enough to reduce the scatter that is inherent in some of the cone beam implementations. So you have high fidelity with the ClearRT images. So here's an example of ClearRT kVCT image without any contrast compared to a planning CT with contrast. And you can see the consistent image quality throughout the image volume. This is a 28 centimeter scan acquired in seconds with the real-time reconstruction. And the imaging dose for this scan was approximately a centigray. This is acquired in normal mode. But if you acquire it in coarse mode, the acquisition is even faster and the imaging dose is also reduced. Okay, this is another example of a ClearRT kVCT image, and this is a prostate case, and you can see the superior soft tissue contrast, which enables more confident patient registration and clear target delineation. So you've probably heard about our PreciseArt, which is our automated daily dose trending and adaptive replanning solution. So with more uniform images that better represent patient anatomy, the ClearRT imaging will further increase the clarity in the review of these patient treatment records, patient treatment trends, and it provides clinicians and patients with access to the highest quality personalized care. So really you can, when you create the patient plan, you can enroll them for automated daily dose trending in PreciseArt with one click. And then as you deliver the fraction each day, all of the ClearRT images are automatically sent over to PreciseArt, and you can view the daily dose trending and evaluate the need for plan adaptation. So in summary, ClearRT helical kVCT on the Radixact system really allows you to see more, know more, and do more. and really, gives you fast, flexible, exceptional imaging. You can know more with the plan adaptation, evaluation, and replanning as needed for the patient. And really, you can treat more patients with reduced patient imaging and registration times. So we have several clinics using ClearRT, but the first clinic in the world to use ClearRT was Willis-Knighton Cancer Center. And we have Dr. Lane Rosen with us today. This is a quote from him, that for lung cancers, they're able to see the lymph nodes in the chest as they change, and the image quality in the mediastinum is better than other modalities available to them. So with that, I would like to invite Dr. Rosen to share his clinical experience with us. I thank you for your attention, and Dr. Rosen, it's a pleasure having you here to share your experience, and the floor is yours.
Thank you very much. I appreciate the opportunity to be here today. I'm Dr. Lane Rosen. I'm the Director of Radiation Oncology at Willis-Knighton for the health system. And I'd like to talk to you a little bit today about our journey from tomotherapy to Radixact and then into the ClearRT system, which has had such a favorable impact on our department. So first off, I don't have any disclosures. All of you are probably familiar with the Radixact system. This is the latest iteration of the tomotherapy system, and it's used all over the world. Our experience with tomotherapy goes back to 2003. How we came to tomotherapy is that in 1997, we initiated rotational IMRT in our department. But at that time, there was a narrow multi-leaf collimator cage that needed to be externally mounted to our linear accelerator, and that only allowed us a very limited 2D portal visualization of the patient. In 1999, we installed two of the first linear accelerators of their type that offered an online imaging system, but we were limited to step and shoot IMRT. So at that time, we had much better portal images, but we had lost the rotational dosimetry that we had become accustomed to. Tomotherapy provided a unique solution for us. So in November of 2003, we treated our first patient with tomotherapy, which gave us the advantage of a helical delivery, but also with the advantages of a three-dimensional megavoltage CT imaging process. I can remember at that time the machine being called a boutique therapy, and people telling us all of the time that rotational IMRT was doomed to fail. So this was our original tomotherapy high-art unit. And notice the name high-art, which was for adaptive radiotherapy. So even back then, that was a goal. Our very first patient on tomotherapy came to us from New Orleans, had a metastatic pancreatic cancer, and had failed chemotherapy. The patient had been recommended to hospice, but sought us out, and our very first patient we treated with what is now called SBRT, or intensity modulated radiosurgery, delivering 9 gray to both the liver and the pancreas for 3 fractions for a total of 27 gray. That patient ended up living for 1.5 years and really changed the way we treated patients. Over the next several years, we were able to treat things that we couldn't conceive of treating before, like bilateral lung cancers and complicated GI malignancies. We were retreating head and neck cancers and treating mesotheliomas, but sparing the center of the lung. We treated the first whole abdominal radiation therapy patient using IMRT with tomotherapy. One of our most interesting cases was using IMRT tomotherapy with image guidance to a patient that had already received radiosurgery to the brainstem. We were able to treat the entire craniospinal axis, protecting the brainstem, and that patient is alive and well today, many, many years after therapy. We treated recurrent esophageal cancers with SBRT techniques, and even treated multiple lesions in the lung. In this case, a patient received 5 different targets, received 48 gray, and the patient did very well with no decrease in their lung performance status. This led us to summarize our own experience with SBRT in the lung, which we still do today, which was able to conclude that using tomotherapy helical IMRT of either 48 or 60 gray in 4 to 5 fractions with PET guidance, that you could achieve excellent favorable outcomes with 94% local control rates. We worked with tomotherapy to help create a white paper for establishing an SBRT program in a clinical oncology practice. And this culminated with us hosting the world's first image-guided intensity modulated conference here in Shreveport, where we had people here from 5 different continents. It was very exciting because this concept of image-guided IMRT was brand new in 2002 and 3. But even back then, it was common for us to look at the newly developed cone beam CT images available on a linear accelerator with those of the images obtained using our tomotherapy. So we were comparing those images even back in 2006 and 2007. And if you notice these cone beam CT images on my left and your left, you'll notice there's not a dramatic difference with some of the cone beam images that you see on your linear accelerators today. And there'll be more on that in a bit. So really what we're talking about is image-guided radiation therapy. Now, imaging during planning and delivery is really the cornerstone of accurate delivery and radiation therapy. And really all of the modern advances in our field have involved image guidance, be it better x-rays, CAT scans, or MRIs. But there are advantages and disadvantages to each of these modalities. All of us who are a little older remember using 2D imaging with x-rays, which really only allowed us to visualize fiducials or bones, and we were very dependent on skin marks and patient immobilization for accuracy and a static diagnostic planning CT scan for simulation. CAT scans were delivered in a room on rails and later with immobile CAT scanners in the unit, and they've been used, but you couldn't share ISO centers with the treatment units, and they really made the workflow very cumbersome. Cone beam CTs, commercial since 2005, offered a diminished quality CAT scan that could be integrated with treatment, and the patient or table motion was not required between imaging and your subsequent therapy. Now, we've gotten better with cone beam CTs over the years through better reconstruction algorithms and software, but there is a limited physics inherent limitation to cone beam CT's growth. Tomotherapy involved mounting a linear accelerator on a CT-like gantry. Most of you are very familiar with this concept, and it used the same radiation source for both treatment and megavoltage imaging. This system absolutely revolutionized image guidance for the field of radiation oncology. Now, in subsequent years, people have used MRIs. There's an MRI guided system introduced in 2012 using a low field strength MRI. And it has software to allow image anatomy to be adapted, but the low magnet strength limited the quality of your images. And claustrophobia and the limited throughput of patients, as well as the high cost of the unit and its vault, have limited widespread acceptance of this modality. Even more recently, we've learned to combine high field strength MRIs, 1.5 Tesla MRIs, with an accelerator. And while that does allow a more accurate diagnostic quality image, it is limited by the field size, as larger fields may reduce the image quality. And limited number of IMRT techniques are currently available, but should improve. Now, that technology clearly has advantages in some soft tissue delineation, but again, you run into serious issues of throughput, claustrophobia, the acquisition price, and the cost of vault renovation or construction really limit its applicability to a limited number of departments. I should also say that physician experience with MRI is limited. And we have an MRI simulator in our department, and I can tell you that we're not as comfortable with that technology as we are historically with CAT scans. PET scans are a newer type of molecular imaging used in radiation therapy with a radio tracer to visualize how normal tissues or tumors are functioning. And it can be integrated with a linear accelerator with the potential to incorporate biology into your treatment planning. At this time, the timing of isotope administration, the ability to differentiate between SUV uptake in malignant or healthy tissues, and what degree of SUV uptake is necessary to guide therapy still need to be further evaluated. Now, this hybrid technology is currently expensive, and while it may offer some clinical advantages, it's unclear if those same advantages cannot be reproduced using current existing technology in a staged manner. So we're really talking about ways of achieving adaptive radiotherapy. Really what adaptive radiotherapy does is it adjusts for the tumor shrinkage or patient changes such as weight loss that cannot simply be corrected by adjustment of your patient position. You have to take the initial treatment plan, apply these changes in anatomy and position, or you can result in an overdose or underdose of both targets and the healthy surrounding tissue. Adaptive radiotherapy allows you to do that. There are, of course, some barriers to adaptive radiotherapy, and it's certainly not for every patient. Some of those include manpower needs, the need for enhanced auto-contouring techniques, dependable deformable registration, image interpretation. But the thing that has really held adaptive radiotherapy down, in my opinion, more than anything, is having a quality, available, rapidly obtained imaging source that can allow visualization of your tumor, patient, and organ changes. Now, most of you are familiar with the concept that you do your treatment planning with a diagnostic CT, you acquire in-room images, you match those in-room reference or adapted images with your reference planning target and correct for position changes. And then there can either be real-time or offline image review before or after therapy, followed by a change in your plan, which is then adapted and applied so that with your next fraction, you can deliver a different type of treatment. Now, that was the goal originally of the tomotherapy machine. We believe that Radixact offers an opportunity to move more freely into adaptive radiotherapy. To add ClearRT is a relatively low-priced unit update cost, and is comparatively low entry compared to the other image-guided radiation techniques that I talked about. It's already incorporated with the tomotherapy helical delivery approach that we're familiar with. Perhaps most importantly is its CAT scan imaging, which is very familiar to my staff and my fellow physicians. There's excellent throughput and efficiency. We've always been able to treat as many patients on tomotherapy in a day as wanted. And most importantly, you get a rapidly obtained near diagnostic quality image. So I'm going to show you some of those images now, and they can be quite striking. In the middle column, you see a brand new diagnostic quality CT simulation image of the pelvis using a couple of different leveling techniques. On the left, you can see the ClearRT images at the same slice, and on the right, the same exact patient, same slice, cone beam images. Now, this is rather striking, the difference in quality. In fact, you could make the argument that the ClearRT images on this slice may be better than that of our diagnostic CT, but that's certainly not the standard. But you don't always need to use your ClearRT images. There are going to be a couple of scenarios where your megavoltage CT, which we've all become accustomed to on the tomotherapy and Radixact systems, may be advantageous. Here's one where a patient has considerable metal artifact. And in this case, in the bottom right corner, you can see where we did a CT simulation using a very advanced reconstruction technique to accommodate, and you can get a decent image and lose some of the artifact. The ClearRT images in this case still have quite a bit of artifact, but the megavoltage CT image in the center seems, in my opinion, to be the best image available in this scenario. Another case where we may prefer a megavoltage CT is in the treatment of this very tiny tumor. In this case, and you may not be able to make out my dose, I've circled the tumor in red, but the megavoltage image was superior for this rare case. But in most cases, we're talking about the comparison between a ClearRT image or the more traditional cone beam images available on other linear accelerators. So patient M, this is a patient where you can practically not see the ventricles on a high quality cone beam CT image compared to the image quality available on the ClearRT image, where you can even make out some of the folds of the brain. This is another image comparing somebody with a lot of sort of artifact and changes in their bones, and the image quality between ClearRT and our CT simulation are quite comparable. In some areas, if you look anterior to the bladder, maybe even superior again. Perhaps the most striking comparison is a recently obtained cone beam image of a patient with lung cancer. This patient had a small amount of metal artifact, but not much, but you still got a lot of scatter and artifact compared to the ClearRT images on the right. And I think that, if you look, these images on the left really aren't that different than some of the images I showed back in 2006 and 2007 when speaking on tomotherapy. This is a video that's a side-by-side comparison of a scan done with contrast on our diagnostic CT and without contrast with ClearRT. Now, I tried to make the leveling a little bit different so that you could see the difference, but I would make the argument that if I changed the leveling and not use contrast, you would be very, very hard-pressed to tell a difference between these two scans. Of course, here we're approaching caudally. We're almost to the top of the uterus. And I believe the scan is nearly completed. Okay. So quite excellent images obtained on ClearRT. What about the time taken to obtain these images? I know Madhavi had talked about the speed with which you can take a meter of image. We actually just sat down and looked at several of our patients and took both a minimum scan time and a maximum scan time. And of course, for the tomotherapy Radixact unit, it's dependent on the length and the technique. And for a cone beam, it's dependent on the gantry speed and the arc length. But generally speaking, the ClearRT images were somewhere in the neighborhood of about 50% faster than our megavoltage images, and nearly 30% faster than our cone beam images. Now that translates to an extra patient a day that could be treated. If you're doing a busy workflow, that's an extra patient that could be treated on your Radixact machine in a daily 30-patient load. So what about our experience upgrading to ClearRT? We've had a long history with Accuray and with tomotherapy. And one of the things that I think Accuray has kind of prided itself on over the years, as we've talked to them, was their service. And in fact, as we went through this process to upgrade to ClearRT, we received daily feedback from Accuray. The feedback was done throughout the installation process. We found the process was deliberate and unrushed. Obviously, they were preparing for any side effects, some issues that they may see as our first site was upgraded. We blocked one work week, and it did take, we blocked a work week for installation of this product. The team ended up using the weekend before and the weekend after, so it was 9 days total. The subsequent site's installation was completed over 2 long 4-day weekends. But this will vary depending on the machine configuration and where the size of the bulb and some other issues. But all in all, our experience with the upgrade was outstanding. So that's our experience with the ClearRT. I believe it can really make a big impact in our practice, and I'm finding that myself and our partners are wanting to place patients on that treatment unit. I'm available to answer any questions, and I really appreciate your attending our seminar this morning.